Okay, we'll start with our quick look at the calendar. The next 2 weeks are going to be a little bit choppy for this class. It's just the way it is. Today we tackle in-context linear problems, that is word problems related to linear phenomena. And then if we take a look at the next class, which is Friday, that's our catch-up day. I don't want you to treat it as an optional day. This is a review day right before our quest, which is coming up on Monday. So come in, regardless of how good or regardless of how well you know the material. Come in, it's a regular class, and you can do old homework or you can do the sample quest problems that are in the packet. And again, the quest is coming up this coming Monday, and it is on classes 6 through 11. So basically the new material for the quest ends at the end of today, okay? But the reason it's going to be a little choppy for us is that after we take that quest on Monday, Wednesday there are no day classes. It's a professional day, so the employees of the school come in, but you guys don't. So we don't have class Wednesday of next week, and then we jump in again on Friday, okay? Any questions on the calendar? We don't have class on the 1st. Yeah, which is Wednesday, okay? All right. So here we are at the top of page 44. Go to the daily summary, Jen. Yes, please. Thank you. Julia, number 1. Cheers. Okay, thank you. Part A, Swan. Okay, so we've got a lot of data in this paragraph here, and we've got 2 variables that are floating around. One of them involves 2009 and 2013. So what's the variable that those things are both measuring? Time. So if time is involved, it is almost certainly the independent variable. I'll say it again. If time is involved, it is almost certainly the independent variable. And we got to make sure we include units here. What is time being measured in? Years. Okay, and then the dependent variable must be the other thing that's being measured. So I see some dollar amounts up here. What are these dollar amounts measuring? It's the value of the market. We got this breathalyzer market. So the dependent variable is the value of the breathalyzer market. And what units are being used for this value? You could say dollars, you could also say millions of dollars. If you say millions of dollars, that saves you having to write 6 zeros at the end of each of these numbers. So how about we do that in millions of dollars? Okay, so once we've got our variables defined, the next thing to do is to start writing these guys as ordered pairs. It says that the data in the problem can be represented by 2 ordered pairs. So let's do that. So first ordered pair. Which one comes first when you're listing numbers in an ordered pair? The independent variable or the dependent variable? Independent, that's the one that comes first. The independent comes first, and then the dependent comes second. So we saw that a few weeks back. So, yeah, 2009, and the value was 215 million. So I'm going to put the 215 second. But then when it comes to the 2009, I mean, literally you could write the number 2009, but that means you're plotting a point at 2009, 215, which is fine. But oftentimes it makes things simpler if we get rid of the, like the 2000 or something like that. So can we change our definition so that we're just saying years since 2000? That'd be okay? It's totally up to you how you define the thing in years, but I'm going to add up here, years since 2000. And if I do that, then I don't have to write the number 2009, literally 2009. What can I write instead? Just plain old 9. And the calculations are just a lot more friendly, and the plotting points is a lot easier if you don't have to plot things out in the 2000s. So this is a very standard thing to do, totally optional, but I think it's a good idea. So we've got 9, 215. That's one data point. Go ahead and take a moment. Write the other data point based on the info in that sentence. Okay, what's the first number? And the second number? 28. And as soon as we've written the coordinates down, then we can do a lot of work on this problem without thinking anything about breathalyzers. These are just 2 points, and we're going to find the equation of the line that connects those 2 points, and that's something you guys have done many times now, okay? So in some sense, we've removed all of the context, and we've got down to just a bare bones algebra problem where we're going to find the line connecting 2 points. So part C says label the axes and plot the 2 ordered pairs. Okay, so if we're labeling, then what goes on the horizontal? Is that the dependent or independent? Independent goes on the horizontal. So then we'll put down here in words years since 2009, since 2000. And then on the vertical, it's going to be money. So I'm just going to write over here, this is the value of, I'll just put market in millions of dollars. Okay, so we've got our axes labeled. We also need to throw some numbers on the axes. Now you could treat everything as ones, like every box could be a 1. And that might be perfectly fine on the bottom, on the horizontal. But on the vertical, what kind of numbers are we trying to get up to? 215, so going by ones is not going to cut it, right? Going by ones on the horizontal, what's the biggest number we're interested in on the horizontal? There's a 9 here, and what is the problem asking us about? It's 13. So, okay, I think ones are like an appropriate unit down here at the bottom. So, so you don't need to label all of them, but I'll just label maybe every 5. 1, 2, 3, 4, 5 there, 6, 7, 8, 9, 10 there, 15 out there, something like that. And coming up with good scales for your graph paper is part of this problem. And it's not something we've really talked about before, but here it is in this problem. Okay, again, we're trying to get up to 215 million. Is the market growing or shrinking, looking at those data points? 2005, it was 28. 2009, you can't read them first to second. You got to read them in year, in time order. And it's growing. So then in 2013, if this trend continues, is going to be more or less than the 215. It's got to be more. So I don't know how much more. Maybe we need to get up to 300 or something. But we got to pick some a scale over here on the left-hand side that's appropriate. So if we go by tens, how many? Let's see, 1, 2, 3, 4, 5. Yeah, it's about 25 of them over here. So tens would get up to 250. We could go by 25s. Okay, let's go by 25. So 25, 50, 75. So maybe every fourth we'll put the number 100. Okay, that's probably good. And again, there's lots of freedom here as you're making these choices. Okay, but now that we've done that decision making, I think it'll be easy to plot our points. So go ahead and plot 9, 15, 9, 215, I should say. Right after I plot a point, I like to put the coordinates so that if I need to reference it later, I'll have it right there. I don't have to look it up again. And then plot the other point at 528. And then you can connect the dots. There's something in the problem saying assume it's a linear thing. Any questions so far? Okay, so now we're going to move on to part D. This is the heart of the problem. It says write the equation of the line that contains those 2 points. Again, it's a process we've done over and over again so far. What's the first thing we need to calculate? Slope, right? No matter how you're finding the equation of a line, got to have slope. And we know slope is change in y over change in x. And so then we'll start doing our subtracting. So upstairs, 215 minus 28. Downstairs, 1 minus 5. I think that's 187. 4. Now let's get a decimal here. What'd you get? Okay. All right, so that's the slope, 46.75. And then if we wanted to find the equation, I think the next step for us has been to write our standard slope-intercept version, y equals mx plus b. And then it's time to start changing a lot of these letters to numbers. So when we're changing the x and the y, you can pick either point. I'm going to pick the point with the smaller numbers in it. You can pick either one. So if I'm picking 5 or 28, which one am I putting for the y? So I've got 28 equals, and we just found 46.75. X has got to be the x from the same point that we picked first. So 5 there. And then plus the b, which we're about to find out. Let's go back one step. Is that Kira? What do we have for this product here? 220. Lydia? 232.35? Okay, good. And that's plus the b. And then we subtract the 233, and what do we get? Good. So just a little bit of work to find the b. And that means that we can take our equation and write it in its final form. Y equals the m, again, we found. X is just x. And then minus the 205.75. Okay, so we've got our equation. two final parts here. One of them says interpret, this is E now, interpret the meaning of the slope, write a sentence in plain English. So the slope was 46.75. So any sentence that you write that's going to get full credit had better include the number 46.75. Sometimes students write these very generic sentences as a slope represents, like it's a rate of change, or maybe they'll get into the specifics of this problem, but you got to give me the 46.75. That is the slope. In order to figure out what the slope represents, some of you might just be able to look at it and know. For me, I need to put some units on these numbers when we did our slope calculation in blue. 215 and 28, what were those? They were millions of dollars, right? And the 9 and the 5, what were they? They were in years. And so that means that the units for the slope, the whole slope, is millions of dollars per year. Millions of dollars per year. So what does it mean? It means that something was changing by 46.75 millions of dollars per year. What was the thing that was changing? It was the market, or the value. So that's our sentence. The market was changing by 46.75 million dollars per year. Okay, and then the final question here says predict the value of personal breathalyzers that the model predicts will be sold in 2013. And so we've got our equation highlighted there in yellow. We're going to use that. It's just a matter of substituting. Either the X or the Y is about to become something like 2013. If you're not sure, don't guess. Take a look back at the ordered pairs that you wrote down. That 2013, is it an X or is it a Y? It's an X, right? Because it's a year. We put years first. So we're going to substitute something for the X. Are we substituting 2013 for the X? Substituting just plain old 13 for the X. So that's what we do. So this equation right here, Y equals 46.75 times the 13 we just said, minus the 205.75. Okay, somebody have a number for us? Alex? 402 exactly? Okay. Yep. And so last part of this is said write a solution, write a sentence, complete sentence. And this sentence better include two numbers. It better include a year and a dollar amount. So in 2013, the market, I don't want to say it will be, should have been, it's expected to be $402 million. Okay, so we did one problem. I think it took us about 17 minutes or so. These are long. So the activity today is 3 problems. 1, 2, 3, that's it. But they're each long. So take your time as you go through them. If you're able to finish all 3 before class ends, you can start the homework, which is more word problems. Raise a flag if I can help.